Welcome to this webinar, this presentation about what should be retired from the Java language. Don't treat this too seriously, but as a teacher, I found as the language has evolved over the years, we sometimes find ourselves using approaches that, well, we learned them back when we first studied Java, and then just kept doing the same thing over and over again. So first, a little bit about me. I currently have this fancy title, Research Scholar in Residence, which is really a polite way of saying I have retired from the classroom after 31 years. I'm a Java champion. I organize the annual J Champions Conference that'll be coming up in January. That's a 4-day set of presentations, all of them streamed directly to YouTube and available immediately. I'm a member of the executive committee of the Java community process. So this is the group that basically is the last stamp of approval for changes to the language. I've just completed my first commercial video. I like to joke that I finally, at my age, got my first ISBN number. It's called Getting Started with Java Programmers for Absolute Beginners. And at the same time, I'm currently writing a book for PACT called Transitioning to Java. In this case, this is a book for developers who are already working in a different language, who find themselves with the sudden need to code in Java. You can follow me on Twitter at OmniProf. I have a blog, which I don't keep up as often as I should, at omnijava.com. So what should be retired from the Java language? Well, we're all familiar with this particular tag, @deprecated. This occurs when components or syntax in the language have been marked for eventual removal. A perfect example of this is probably the old date class, for which pretty much every single method in the date class has been deprecated. And of course, we now finally have a beautiful time API. So deprecated means, well, it's still there, but it could go at any moment. When your IDE or in your reading turns it up, you really should not be using it. Now, what I'm presenting is a new annotation that I've called @retired. It does not exist. Do not try and use it. You'll get strange error messages. But as I said at the beginning, I'm interested in approaches, classes, methods, even syntax that have pretty much remained unchanged since version 1 of Java, yet have been superseded by newer techniques, newer classes. And so that's what we're going to talk about. These items are not going to be removed from the language. Far too many developers, far too many projects out there depend on this, shall we say, old style of coding. I believe in going forward, you should not continue to use these particular items. So with that out of the way, let's take a look. I have a selection of 10 items I have chosen that I believe should be retired from the language. And when I finish, I'd be curious to hear if you have any suggestions for what you think it's time to say goodbye in the Java language. Let's begin with retiree number 1, looping. So we all learned how to write a for loop in pretty much whatever language we started with. You can see the first example, right? I have a list of strings with the names of planets, and my intention is to display the contents of every item. Or thinking of it another way, you need to visit every item in the collection to perform some action or another. So there's our original for loop. This is the style that comes to us all the way back. Gee, this loop is, although, well, it's fundamentally the same as the first loop I saw when I learned to program in AppleSoft BASIC in 1980, right? The basic for loop. This particular syntax came to us from C. Well, then Java evolved and we got the enhanced for loop, or some people call it the for each loop, where we didn't have to deal with the index, but we could now simplify the expression to, or the statement, to allow us to access each and every element. But right at the bottom there, I should have made it bigger, are two modern ways to visit every element in a collection. We have our for each, or we can introduce a stream between the collection and for each. And in both of these cases, we're using functional notation to indicate what we want to do with each element. As someone who's constantly confronted with statements like, oh, Java's too verbose, there's too much boilerplate, there's too many things you have to write. I think the original for loop is a perfect example of a lot of boilerplate. If you're writing code to examine, access, work with elements of a collection, stop using for loops. It's time to use for each and streams. Retiree number 2, how we declare and instantiate local variables. Now, as I say in the first point there, we can almost consider this, well, semi-retired, because we can only use this technique for local variables and methods and not for the instance or fields of a class. So let's look at the retired version. Nothing particularly unusual about this. I'm declaring the fact that I'd like a list of strings, and I'm using the utility method arrays as list to take this list of literals and return it. Or in the second case, I have two approaches to this, either arrays as list or list of. Both of these produce the same thing. And certainly if we were to bring in a Python programmer and say, what do you think of this? They're going to go, what's all this list stuff on the left? I see list on the right. There's just a lot of stuff here for a very simple operation. And that's where our friend var comes in. Var eliminates all the need for type on the left-hand side, right? The compiler has always known what type based on the right-hand side. So there became no need to repeat it on the left. And this is, again, leads to this belief that Java is, well, you got to write a lot of stuff. Gee, Python is so small, or pick a language. I don't want to single out necessarily Python, but everyone likes to say we write too much as Java programmers. Well, we don't have to. Oh, a few words about var, just to be a little clearer. Well, common complaint, I've already said this too many times. Use var for declaring local variables. Get into this habit. Now, a couple things to keep in mind. There are things to worry about. For instance, in my first little example here, well, there's an old issue. I can't use an interface class on the right-hand side, right? So I can't put lists there. But because I used as list and list of, I should remind you that in the first case, as list, it gives us a fixed length. We can't add to it. We can't shrink it, but we can change the elements. And that in the second case, var must list of, it's a fixed length and immutable. And more as I read and look at code, we're beginning to see that immutable tends to be the safest way to go. Objects that can be changed have always posed a problem.
Could you try again?
That was my watch deciding that I just spoke to it. And now it's recording everything I want. Okay, I've silenced my watch. Boy, all our devices talking to us. Retiree number 3. We are looking at the classic C or C++ switch. When I was preparing this, I asked myself, when was this particular syntax first introduced? And I discovered it actually comes to us from the 1950s. The idea that a switch looks for a comparison for equality, right? We're looking to see if point matches either north, south, east, or west. Looking at those words, north, south, east, and west, we know they are constants. And because of the initial nature of switch, they also had to be integers. But we know Java now allows us to compare to strings. But then there's other things that have always driven me crazy. For instance, the break. Why the break? You know, as a teacher and reviewing books for the classroom, it seems that every textbook wants to show you a switch dealing with the days of the week, where you say things like case 1 and 2 is Saturday and Sunday, and case 3 through 7 are weekdays, or other silly things, and you leave out breaks, you include breaks. I cannot remember the last time I thought it was appropriate to allow more than one case to go true. And yet, the need to break is simply another reason for something to go wrong. Well, recently, Java moved into the 21st century, so to speak, and we've gotten 3 new versions of the switch. And between the 3, you should never use that first one. So let's begin with the expression switch. I love this one. Just looking at it, this is the equivalent of what we just saw in the previous slide. For the first time, switch returns a result. There's no need to do assignments in the case. We simply say whichever case is true, that's the value the switch will return. There's no break. If a case goes true, that's it. We're returning the answer. We've cut this down. I'm going to go back quickly for a moment. You get a sense of how large that is, how much you have to code, and then we have this, the expression. Remember, expressions return values, but if you're not returning values, rather the purpose of your switch is to define a set of additional operations, well, that's when we use the new statement. Similar, though there's nothing to be returned, here we're simply calling other methods in our application. One of the things, as I say from time to time as a teacher, is pointing out to students that you do not want to perform tasks in a case. You should be calling methods to do the work that you want. And so in this example, we can see we can call a single method, create a block. We can call multiple methods. We have, again, simplified. I feel confident that even if we took somebody who knew nothing about programming, they'd probably figure out what was going on here. Show them a break, and all they're thinking about is dropping dishes on the floor and watching them break. No, breaks got to go. But wait, there's more. So I'm an old timer. There was a recent statement made that fascinated me. It said the difference between 1918 and 1970 is the same as the distance between 1970 and today. A lot of time has passed for me. And at least in the 1980s, I was programming professionally in a language called Visual Basic 6. So this was a structured version of the Visual Basic language, and I was working with it. And one of the things that I admired from Visual Basic 6 was its form of the switch statement. So notice here, it would begin with the phrase switch case and then value. And then we have the cases. But look at the cases. In the first case, case 1, well, nothing special there. That could have been the same as for C or C++ or Java. But then we have a case for a range, 1 to 5. We have a case to match elements in a list. We have a case where we can use logical operators. Heck, we can have a list, logical operators, individual items. I love this switch. In almost all cases, it allowed me to eliminate if statements all over the place because I could effectively make whatever comparison made sense in the switch. Well, if you haven't read about it, guess what? We get one too in Java finally. Now, currently, it is just in preview. What we're going to look at is the syntax for Java 19, which hasn't, I don't think it's gone live yet. I'm hoping it will go from preview to final for Java 20. So let's take a look at this pattern matching switch. Well, currently at 19, finally get my Visual Basic 6 switch. And I'm willing to bet there's probably no one here today who remembers Visual Basic 6. You've all heard of VB as part of .NET, but you've probably never seen the structured Visual Basic. So let's take a look at this. The first line, object value equals 4. Effectively, this could be any declaration of an object. The fact that it says object isn't as significant as the fact that what we're assigning to it is a 4, which through the feature of auto boxing will result in that object being of type integer. We could have also just declared an integer, but in this case, what's important is in the switch, in those parentheses, we need a reference to an object. So object value equals 4. Now our cases. Our cases now are not looking for a match on the value. Gee, I use the word value too often, with the numeric significance of value, right? We're not looking for 4. What we're looking for in a pattern matching switch is the same type. So the first case, case null. One of the evils of Java that we always have to worry about. So case null, if value is null, we would print out this first statement. We could call other methods, whatever we want. In the second case, string. So here we're saying, is that value object actually of type string? And if it is, well, we're going to print out the message string. But it's the third one, the case integer, that shows us how what I was fond of in Visual Basic is now available to us in Java. Because we begin the same, case integer I. So this case will be matched if value is of type integer. But we include a new keyword called when. If you've seen this before, up until 19, double ampersands were used. Java 19 replaced the double ampersand after the type with the word when, which I think makes more sense. But after the when, it's whatever you'd like, that you can start creating logical expressions. In this example, I'm looking for a value between 1 and 6. And then, of course, our default. I'm really excited to see this pattern matching switch. I can't wait for it to go to production and allow us to write more efficient code. Ah, yes, retiree number 4, System.out.print, println, and as I call it, the evil concatenation. So we've all seen this, System.out.println, some text, then a variable, then more text, then another variable. I'm sure many of you have ended up writing System.out.printlns with multiple pluses and concatenation and everything else. Now, I came to Java after teaching and working in C++. And although Java was always about being better than C++ or dealing with its weaknesses, though they didn't always get it right. But probably one thing they saw as a weakness, I actually saw as a strength. And so I was excited to see it return to the language, a way to defeat, to get rid of this nasty concatenation syntax. And that is System.out.printf. It is similar to the C printf. That's one of the things I missed in going from C, C++ to Java. Now that same statement, and this would be pretty much identical to what you might write in C and C++, I now use placeholders for the variables I wish to display in the string. No need for all that concatenation. And as a bonus, these placeholders can also contain formatting information. We can determine how many decimal places we want. For floating point, we can even define how a date should appear using the syntax in System.out.printf. I think for many people, they look at this and go, well, that's the old way of doing it. The Java way is concatenation. Well, I don't think so anymore. I'm much preferring printf, and I guess in situations where I may have no other choice, though I can't imagine when that is, I'm using printf for everything. I've retired println. Retiree number 5, literal strings. I suspect what I'm about to show you is something you may be familiar with. Certainly, it is an important tool here in Canada. So let me explain. As I point out here, despite the country to the south of me, and if you don't have a map in front of me, that's the United States of America, English is not the only language in the world. I sometimes have fun with American developers when I'm at a conference and I try and discuss this concept. And they look at me like I'm, well, not speaking English. What I'm saying is it's time to retire your literals if you're still using them. I would believe many of you are not any longer, because in your part of the world, you're surrounded with a myriad of languages, and whatever you're doing, you'd like everyone, despite the language they speak, to buy your stuff. So literals and resource bundles. So for instance, I've just grabbed this line of code. This is from a GUI. I think this is probably from JavaFX. I need to put text on the screen, and I'm going to say select cheese. But there's the literal. If I suddenly discover, and let's use Canada as an example, I've written this in English, but of course, we have 2 official languages. Software in Canada is expected to run in both English and French. You don't want to have 2 different code bases for the individual languages. The solution is the resource bundle. And a resource bundle, which sounds kind of, ooh, this looks complicated, is really nothing more than an ordinary properties file. It follows all the rules of a property file. We have a key on the left, a value on the right. I can have a properties file for each language. The code base remains the same, but the language changes. So with a resource bundle, I can first assign the bundle to a variable. So here I'm assigning it to MSG. And now I'm in a position to get the particular key. So the key will be whatever language you speak, whatever you're most common with. But Java is smart enough to recognize the locale the application is running on, or in the case of a web application, it can recognize the locale of the user's browser. And with that information, it can automatically select the appropriate bundles. The bundles are named with the standard locale identifiers. In Canada, I think it's CAEN or CAFR, depending on whether it's English or French. We've got to get the word out. We have to stop using literal strings. We've got to retire them. Retiree number 6. I have to admit, there's a couple of Java developers at Oracle, the architects of the language, who think I'm just a little crazy over this. So again, going back to C, because it is the, is it the root of all evil? Well, I don't think so, but it is the, the model upon which Java was certainly built. And we knew that we needed an entry point, someplace our program had to begin. And if you don't remember in C or C++, oh, never bothered to learn, you didn't have to. There can only be one main method. I always thought it fascinating that the developers of Java said, we can have as many mains as we want. Every class can have a main. And then just simply decide which one of them will be the starting version. C, C++, only one main that's determined by the compiler linker, and that's where your program begins. Great. But as I point out here in C, the main method is just one of the gang. In C, as a structured language, they're all methods. The only thing special about main is it is the first one chosen. C++ continued this, which kind of made sense. And then Java decided to hold on to this relic, as I call it. Yes, they added, you can have more than one. So I tend to think that just muddied or confused people more than providing them this, well, interesting feature of multiple mains. So why do I want to get rid of it? Well, let's take a look at this. You've probably all seen this program. Pretty much every book I come across, Learn to Program, has some variation of this where you are expected to be blown away by having the phrase "Hello World" displayed on your console display, your console screen. My first program in BASIC was print "Hello World," and now I was convinced I was a professional programmer. What's the problem with this? Well, this isn't object-oriented programming. Java demands that main be static. Has to be because the JVM has to be able to call this method without instantiating hello world. So we need this static method. Great. On the surface, that looks fine. You're going to get your hello world or whatever you want to say, and now you're excited. And then as you go ahead and learn more about the language, you learn about, well, loops, if statements, assignments. And most books tend to do all that learning here in main. My last year of teaching, I assigned my students a simple project so that I could assess their skills. I was teaching in the final year of the program at Dawson College here in Montreal, and I was responsible for the project courses. We would typically do a desktop project. More often than not, we did a kind of subset of Microsoft Outlook. We built in JavaFX an email client. And then the following semester would be the web project. This would be an e-commerce site they would develop. So when I would meet them for the first time in the fall, I would give them an assignment and explain to them that I was going to grade their assignment. They would see what mark they would get, but it wouldn't count. They didn't know me, I didn't know them. let's get to know each other by submitting work that I will grade just to get to know me. Well, I would have students who would code the entire assignment in main. They use what I like to call the stream of consciousness approach. And why did they do this? It's because they would see on Stack Overflow, any place they searched on the internet, that static is good. Static gets rid of all that object stuff that they don't want to know about. And it works, right? That's the sole purpose of code, to work. Well, not quite. And I blame every book, and I have to admit, I probably did this at the beginning of my teaching career, blame every teacher who thought this was how you present someone's first program in an object-oriented environment. This is how I teach the very first program. This is an object-oriented program. To be able to get to the method perform, you must instantiate an object. I actually forbid my students from using static anything without meeting with me to justify why they believe, whether it's a static variable or a static method, has a reason for being in our object-oriented world. We make everything static. Java now is effectively C. If we believe in object-oriented programming, and maybe you don't, but if you do, then that main has to have as minimal an impact on the application. Heck, I'm not even bothering to declare a variable for hello world. I'm using an anonymous reference and simply calling the first method. From there, perform, and the name isn't significant, use whatever name you like. Perform is the real manager of the application, and which may go on to create other objects. Be careful here. Some people may believe, well, isn't that what the constructor is for? Well, no, the constructor is for constructing, not for actually doing any work. Create a method to manage your program in this object-oriented environment. Benchmarking. So some time ago, I would do a presentation in a class where I would show how different collections perform. So for instance, here's just a fragment of code I had used in that application. Application was kind of cute. It was a swing table. And so I would perform a number of operations with sequential data structures, lists, arrays, and decks and queues, and then or linked lists. And then I would do another set of operations on the map structure, the hash map or the tree map. And I would demonstrate, and it did demonstrate what I wanted, that some collections were superior to others, right? The hash map effectively of the trees of the maps is the most effective. How would I do that? Well, I'm sure some of you have done this already. I go off and I record the nano, the millionth of a second time, just before I start the operation. And here you can see all I'm doing is I'm filling a hash map. And I'm kind of being a little cheap here because I'm using the key and the value to be the same thing. And I'm filling this hash map with 1,000 items. These, by the way, are all strings. And then I record the nano time at the end, subtract the start time. That tells me how long it is. And the last running total, well, I'm keeping an average going. I usually perform this operation about 1,000 times and then present the average value. Well, certainly when I create this application, when I look at the tables, I am getting the results I expect, right? Arrays are fast in certain things. Linked lists are really slow. I just struck me what I'm really talking about here is trying to show my students big O notation, how we begin the process of selecting an appropriate data type. And big O is one of the things we can use. And this particular application demonstrated it. The problem is it neglects a number of important problems. This is where the Java Microbenchmark harness, gee, why call anything a harness? I don't know. But the Microbenchmark harness is now a library and, in this case, annotations that we can add to our code. We can say, for instance, that this method here, pretty much the same method, but without the need for nano time or anything, that I want this benchmarked. Fork, how many times do I want this to run? How many, how many times? So warm-ups. This is something I hadn't realized until just a few years ago, that the JVM gets faster the longer it runs. It reaches a certain point, it's not going to get any faster. But if you run an application in a fresh JVM or run an application in what I will call a mature or long-running JVM, the second version of the code will likely run longer. So if we really want to get an honest assessment of how fast our code is running, well, we want to warm up the JVM. And warming up is easy. We're simply going to run this method, right? We're going to go off and fill in the 1,000 items. I'm using size for that so I can adjust it. And it will perform this however many times. The next annotation says we're going to warm this up 5 times. So we're going to do this 5 times and not even count those answers. They're thrown away. And then we will do the actual values for testing. Come back to fork. I've set this so it's only going to run once, but I could run it multiple times. Each run, you see iterations under measurement. My time unit, different time units for different items. But now I'm going to have an honest assessment of the performance. The Microbenchmark harness was developed by the Java team at Oracle. If there's anyone who knows how to measure the performance of code, it has to be, well, Brian Getz and the rest of the team. The output of the Microbenchmark harness is this table showing you the average score. I'm using nanoseconds, so that's why the numbers are so large. And it does tell us what we expect. Dealing with a hash map is far more efficient than dealing with trees, whether sets or, of course, tree maps, the worst of the lot. The error is telling us the maximum difference between runs. We know there's a lot of factors that can affect it, but we have an honest assessment of what's here. I'm currently working on a new presentation, Java benchmark harness, and one of my goals is actually to capture this report and display it in a Java FX table rather than having it just appear in the console. Keep an eye out for it. Somewhere online, I'll be giving this presentation in the future. Retiree number 8. Well, this is an easy one. The debugging with System.out.print. Sometimes when I was in the classroom, I'd be walking through the lab and I would imagine myself in some old movie in the 40s or the 30s, and I would have a wooden ruler and I would walk by a student and I would see them write System.out.print, X equals, and then I would use my wooden ruler and wrap them on the knuckles. Debugging is not the domain of System.out. Stop using any of them, not even printf. It's why loggers are there. Log, 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 log. I actually just started a discussion on Twitter yesterday. Should we be using SLF for J, log for J, a number of others, or should we just be using Joule as our logger? It's interesting to see the opinions. Follow me on Twitter at OmniProf, another plug, and get to see a lot of opinions of how people think. Does it matter what logger you use? Is the built-in Java logger sufficient? Are you hamstrung into using a particular one? Regardless of the logging framework that you use, log. Not System.out, not System.air. Use logging. Retiree number 9. We're coming to the end of our list here. Retiree number 9, the immutable Java B. So look on the left, there's my @retired annotation. Here I have an immutable B. And it's immutable because A, it can only be initialized through the constructor, and it only has get methods. Get name, get salary, we initialize it. There are no setters. My advice to you, anytime you're trying to figure out the best data structure, how to organize your variables, think about immutability. If your code has to generate new objects for changes, you are less likely to be making the wrong changes or changes at the wrong time. So there's my immutable Java bean on the left, nothing special, but back to something we started with, that issue of verbosity, which is an English term for saying writing way too much stuff. Take a look at the new record class. What you see on the right is effectively identical to what you see on the left. That's the kind of line that would warm the heart of a Python programmer. And of course, our records are similar to their tuples. In my little block of code, we can see how we use the two approaches, the retired and the current. AB equals new a bean, AR equals new a record. Nothing fancy there. The only little difference, of course, is records don't use the prefix get. They're immutable, so there never was going to be a set, but they don't use the get. They simply use the name of the variable. So ar.name is the equivalent of getting the name in our regular bean. We have simplified our code and, by virtue of immutability, made it more secure. One more to go. New. This one always baffled me. So Java's inventors, James Gosling, a fellow Canadian, I've had the good fortune of meeting him, though I'm fairly certain he doesn't remember me at all, but that's okay. Java's inventors realized there's a problem with the delete operator. Excuse me. And that was that developers were forgetting to call delete. I always love the expression memory leak, right? It's not that memory is being lost, memory is becoming inaccessible because it is not being released. The Java people came up with, or I can't say came up with, this concept was there before them, but brought into Java the idea of garbage collection, that the JVM could monitor the scope of every reference, and when a reference went out of scope, it got added to the list to be released from memory automatically. There is no delete in Java, as you know. Now, they did add a method called finalize, which I remember, switching from C++ to Java, recognizing immediately that finalize made no sense at all. As a matter of fact, even the Java architects realized that when they deprecated it in 11. So finalize is deprecated. And of course, the problem with finalize is it is only called when garbage collection happens, which if you happen to have a computer with a lot of RAM, machine I'm sitting in front of has 32 gigabytes of RAM, a little bit more than my first computer that had 48K of RAM. Well, I could probably run Java applications that might perform garbage collection every couple hours, maybe even every couple of days. But if I'm waiting for something to occur at the point at which a reference goes out of scope, ain't going to happen in Java if we're using finalize. We have to explicitly call our own method. So Java took care of delete, took care of garbage collection, fine. But they left new around. Leaving new around created something that always, well, I won't say confused me, and I even took advantage of it. The fact that a reference has 3 states, right? We have binary computers, it's 0 or 1. But references are kind of 0, 1, or 2. What I mean by that is a reference is null, a reference is valid, or a reference is invalid. A lot has been written of the evils of null, first of all. And then, of course, there's the issue of invalid references. Class or field references are all initialized to null, but local references are not. So suddenly, if you're checking the state of a reference, just asking if it's null or not is not enough to tell you if it's valid. You have to instantiate it. My question is, why isn't the JVM handling this the way it handles delete? Why can't, upon first use of a reference, have the JVM instantiate the object? Now, I can hear, and I've mentioned Brian before, I can hear him, speaking in my ears, telling me every reason this can't work. And I don't disagree with him. But I have to tell you that when I encountered context dependency injection, CDI, that I first came across in web programming, I went, wait a minute, this makes so much more sense. On first use, just declare it for me. Don't make me worry about, did I say new? Is the reference valid? The 3 states no longer exist when we use something like CDI. And what I think many developers are unaware of is, though CDI is associated with the web, you can also use CDI on the desktop. There's no reason a JavaFX application can't use CDI to manage most, if not all, of the objects it creates. Oh yes, as a little extra, look at bean validation. Another great way when you're using a bean-like structure to separate data from its actions, we have to deal with validation. Well, that's enough of me telling you what I want to change. I'm going to stop sharing my screen, and I'm curious if any of you have structures that you'd like to see changed or just want to tell me I'm crazy. Let's take this off, stop share. There I am. Hi, everyone. So any comments, questions? I'll even open up the chat here. I notice there's 2 messages there. Oh, good. You can either speak or you can type a message. I notice everybody's muted. That may be the case. The other day when I gave this presentation, where did I give this presentation last? It's funny, as we all speak online from our homes, you keep forgetting where you were. So I gave this presentation in Romania. I forget where the last place was. One of the things that came up is, what about other things that we could retire? And one of the things that I have, I dropped years ago was my preference for Java server faces over JSP, Java server pages. Whoa, was that? I watched students develop web applications that were functional but bland using Java server pages to suddenly becoming works of art with Java server faces. So I see a question here. Somebody's asking me about changing main and stuff. It was Kay Horseman, an author. Maybe some of you have read his books. I had an opportunity to meet with him in Crete, and we talked about allowing the JVM through annotations simply to be told which object it should instantiate automatically first and transfer control to a constructor. And this could be one way to eliminate main. Any other comments or strange things about what I've said? No, I think either everyone is stunned or everybody's going, yeah, that's right. I think I'll go for the second one. So thank you all. I see our moderator is back online. I'm always happy to answer questions. Again, get to me through Twitter. I hate Stack Overflow. I much prefer using Twitter. I get better answers because they have to be short. Okay, that's enough of me. Thank you all for coming.